So today it's a VHDL. If you guys hear about VHDL, what do you guys think about? VHS. VH1? Ultra Max Plus는 뭐야? Video Home Downware? What is L then? 이게 뭐게요? Oh, you guys don't even see it. Video Home Downware가 뭐야? Video Home Downware. 다운로드구나. Or 삼별초님, did you look it up? Hardware description. 오, 배운 거야 이거? 혼돈이? Okay, so VHDL stands for VHSIC Hardware Description Language. Description language. Which stands for HDL, Hardware Description Language. So it must deal with hardware, right? That can model the behavior and structure of digital systems at multiple levels of abstraction, ranging from the system level down to that of logic gates, for design entry, documentation, and verification purposes. Since 1987, VHDL has been standardized by the Institute of Electrical and Electronics Engineer. Ah, so it's for electrical engineer language네. Oh, anyone electrical engineer? Electrical engineer. The latest version of which is IEEE-STD. Oh. Oh. So it is named after US Department of Defense program that created it, the Very High Speed Integrated Circuit Program. Ah, so VHSIC is very oh sorry. This means very high speed integrated circuit program. Oh, oh shoot. 뭐라고? 그리고 다시 쳐다보지 않았다고? 쌉 인정. 어려웠구나. Valhalla Dead Life? What the heck is VHDL이 Valhalla Dead Life라고? Yeah, okay, so I already have a different lighting service thingy, but it still makes my skin dark. If you have a problem, can we stop mentioning about it? Like half the chat's about that. So yeah, so it's actually VH. So this whole thing is VHSICHDL. Right? 아니, 여기 뭔 소리야? 전공분들이 많다니. 안 보여? 다 못 알아듣는다잖아. 아, 나 too. 아, 오. Wow, so the actual full name for this should be VHSICHDL. 겁나 머리 아프네. So let's read more about it. So it seems that it started in United States. Why am I writing this? Hold on. Department of Defense, DOD. 이것도 let's shorten everything, guys. If you are a college student, remember, when you're taking notes, try to shorten everything. So in the early 1980s, the VHSIC program sought a new HDL for use in the design of the integrated circuits it aimed to develop. The product of this effort was VHDL version 7.2, released in 1985. The effort to standardize it as an IEEE standard began in the following year. Whoa, 뭐야? Who studies this? Who actually have used this at work? Who used this? IEEE? 아니. IEEE. What the fudge? Hope it's not in the exam. So in 19, so let's learn the history. 1983, VHDL originally developed at the behest of the United States Department of Defense in order to document the behavior of the ASIC. Oh, so VHDL is to use ASIC. Who knows what ASIC is? ASIC이 뭔지 아는 사람. That supplier companies were including in equipment. The standard MIL STD 454N is requirement 64 in section 4.5. Wow. So here, the idea of being able to simulate the ASICs from the information in this documentation was so obviously attractive that logic simulators were developed that could read the VHDL files. The next step was the development of logic synthesis tools that read the VHDL and output a definition of the physical implementation of the circuit. So VHDL is mostly used for the circuit system language in ASIC. Right? I think that's what it means. Wow. So, due to the DoD requiring as much of the syntax as possible to be based on ADA, in order to avoid the reinventing concept that had already been thoroughly tested in the development of ADA, VHDL borrows heavily from the ADA programming language in both concept and syntax. 무슨 소리야? What the hell does that mean? Well, okay. So a problem not solved by this addition, however, was multi-valued logic, where a signal drives strength, non-weak or strong, and unknown values are also considered. This required IEEE standard 1164, which defines the 9-value logic types. 뭔 소리야? Oh, guys, is this thing speaking English? Hi, Kuya. Is this in English? What is it saying, guys? Oh my god. Okay, let's try to understand this. So, due So Ada, guys, is a different programming language. But DoD required a lot of syntax to avoid reinventing concepts that has been already thorough. VHDL, it uses a lot of Ada programming language. So it is a language based on Ada, but uses lots of syntax. 네? 아니, not that. Right? Are we talking about Star Wars universe? What the Initial version of the language could not account for signal values that were not distinctly 0 or 1. Oh. So let's kind of move on. So I think this is important. So a problem not solved by this addition. So the addition IEEE 10761987 could not solve the issue, the problem, but was multi-valued logic. Oops, sorry guys. Where a signal's drive strength and unknown values are also considered. This required IEEE standard, which defines the 9-value logic type, scalar and its vector version. Being a resolved subtype of its parent type, STD logic type signals are multiple driving for modeling bus structures, whereby the connected resolution function handles conflicting assignments adequately. So it seems like an app that is used for hardware programming. Hardware programming. That's why it's called the hardware description language. So maybe it's not actual programming, but just to kind of what the hell is this supposed to do? It seems that it's just a way to document the behavior of ASIC. It is basically what VHDL is supposed to do, but as time developed, it's just a language to document a behavior for any electrical circuits. Right? Oh, sorry, Cruz. Oh, ooh. How'd you know my posture sucked? Yeah. So what is logic gates, guys? They've mentioned a lot about logic gate. What the fudge? Sorry, guys. So what is logic gate? Logic gate is AND or not XOR. Sorry, Stack. I was like, I thought you were being logical, and then you were yelling at me saying it's logical, not logic. Sorry. Okay. If you have two incoming signals, the gate determines what the result should be. Oh, it's a gate to transform input. Oh. So can I try to make a strong guess on saying this language is, it seems that since it uses the word description, it's a way to document oh, sorry, I can't spell document. Oh my god. Sorry, oh my god, what the hell? Gonna, sorry, document. Sorry, I was gonna add documentation and then I like stopped at sorry, documentation, the behavior of ASIC or any electrical hardware, right? But I think here, when they talk about the word behavior, this defines what you guys are saying about the logic gates. So what are the inputs that are returning after the hardware gates is being done? Right? Does that sound legit? Is this kind of correct? You know what I mean? Does it make sense? So let's talk about design. So they have design in Wikipedia. VHDL is generally used to write text models that describe a logic circuit. Such a model is preceded by a synthesis program, only if it is part of the logic design. So if logic circuits, now what is logic gates and what is logic circuit? Oh, fudgy. Logic circuit. Because it's saying a simulation program is used to test the logic design using simulation models to represent the logic circuits that interfere to the design. This collection of simulation models is commonly called a test bench. 저도 ABC 몰라요. 이거는 완전 나랑 완전 정반대. 나도 이쪽 모르겠어. So VHDL simulator is typically an event-driven simulator. This means that each transaction is added to an event queue for a specific scheduled time. If a signal assignment should occur after 1 nanosecond, the event is added to the queue for time plus 1 nanosecond. Wow. I still don't see the purpose of this language. The key advantage of VHDL when used for systems design is that it's allowed the behavior of the required system to be described and verified before a synthesis tool translates the design into real hardware. So this basically, you can program the circuit and test it as if it's into a real hardware and see how it acts. So it seems describe means how it's being used, and verified is saying if it's going well, right? And so the another benefit is that the VHDL allows the description of a concurrent system. VHDL is a data flow language in which every statement is considered for execution simultaneously, unlike procedural computing languages such as BASIC, C, and assembly code. So every statement is executed right away. Wow. So this is an example of design. Wow. Oh my, sorry guys. This is why I was never an EE, guys. Wow! What is going on? Holy cow. Testing environment. So I think that's testing environment. Not only does it define what it does, but I think it also verifies that if it's doing it well. So not only it's description, or yeah, description, hardware description language, not too. It also see how the circuit is going well, or if it's functioning as it's supposed to. Oh, I've heard that that's the advantage of an emulator. Oh, give certain inputs, the hardware will give you certain outputs. Yeah. Okay, I got it. So every EE does this. Right? Every electrical engineer does this. 인정? Agree? So this is a VHDL comment. So you can comment like this or like this. So what it does is it imports the logic. So std logic means that it's importing the logic called library IEEE, which means, and use the 1164 logic, because that's the recent logic. And actually, this is kind of lot. Here it says verbose for HDL beginners. I think bunch of these can be limited into 1 or 2 lines, or don't even need it at all. So. But actually, experienced designer usually avoid compact form and use actually lots of writing for readability and maintainability. Maintainability, Jinri. Maintainability. Guys, I can't speak English. So it's just like a log on keeping how this circuit will work, so that if this circuit goes, maybe has an issue and another person has to check it, they can check the code and see how it's being functioned and if there's any code issue going on. Or use this to test if the circuit is going well or not, right? So this is an entity, okay? So they are creating an entity. So it's saying AND gate is port in, out. So 2 in and 1 out, and then they're gonna end the entity called end gate. Now they also create an architecture where the end gate starts. So it's for this, it's just one-way circuit이구나. So in terms of circuit form, it's just gonna be in, out, in. It goes this way, right? In 1, in 2. 이런 식으로. And then it ends. Oh, I think I'm getting it, right? Does this sound legit? So it feels a bit like C++ with declaration and implementation. I guess so. So that's why it's saying this code is simultaneously done, because here I think is the architecture part basically gives you the output right away. 와, 진짜 이딴 거 누가 해? Why do some people do this? So VHDL simulators in commercial, so it seems that it's used in LDIC active HDL. So let's see where it's being used. LDIC? LDEC. Sorry, that's an E. Active HDL. What is this? Oh. Mentor Graphic Model Sim. Cadence Incisive. Mentor Graphic Cresta Advanced Simulator. So the fact that it's saying it's a simulator, I think it's also for test ground, right? You can actually try it on EDA Playground, which is a free web browser-based VHDL IDE. Oh, wait, I just want to see how it looks like. Let's try it. So it looks like this. Wow. So my test bench is here. My design bench is here. Sure. How do you... I want to try though. Wait. So I'm guessing design bench goes here, right? But I think this should be comment. How do you test it though? Wait, I don't think this is true, right? Or maybe do you put this here? That's what I was thinking. You need to change the dropout on the left to VDH. Oh! No wonder! Oh! No wonder! Oh! Code your test bench here. Oh. Oh. Delete. 그 다음에 no. How do I test? Enter! 그런데 you need also design bench. No? Run, sorry. Select a tool. Tool. Where's the tool? Let's try Mentor. 아, commercial? 이렇게 하고 what? You must log in. Oh man! They're making us. Well, if you guys want to test it out, you can log in. 자, conclusion. If you don't like circuits, please. Oops. Oh fuck. Oh, there you go. Please press the back button. Conclusion 1. If you don't like circuits, please press the back button. 그 다음에 I applaud people who use this. Anyways, just the real conclusion, I want to say it's a description and simulator for electrical hardware. Electrical circuit. For electrical circuit inside hardware. And finally, good luck. The end.